In this section, we will introduce Apache Storm. Let's compare first Storm and Hadoop. First of all, Storm and Hadoop do not compete with each other, they complement each other. We will find several common characteristics. First, both of them run on clusters, both have master and worker nodes, and both of them use Zookeeper for cluster management. Now, Hadoop and Storm will differ in the following areas. Hadoop is oriented towards batch processing of large files that are stored on HDFS, and when you run a job on Hadoop, it will run to its completion. On the other hand, Storm will process the data in real time as the data comes into the system. The jobs run forever and they process the data that come in. Conceptually, Storm systems consist of spouts and bolts that have a particular set of functions. So let's see what they are. Spouts are sources of streams. Bolts would consume the streams and they would be emitting tuples. This whole thing together is called the topology. The flows of data between the bolts or between the spouts and the bolts are called streams, and they are unbound sequence of tuples. And tuples are lists of key and value pairs. Physical organization of Storm cluster is also interesting. We have a number of parts here. On the left-hand side, everything begins with Nimbus, which is the master daemon process. It distributes the code, it assigns the task, and monitors failures. We already mentioned that Storm uses a Zookeeper for cluster organization. The operational state of the cluster is stored on Zookeeper. Within a Zookeeper, we have a number of supervisors, and a supervisor is a daemon that is listening for work. The supervisor will organize the work of a worker process. A worker process will consist of a Java process that executes a part of this topology. And this worker process will use Java threads, we call them executors, to eventually execute the tasks, which are component instances that are doing the processing. Besides the relatively low-level API with spouts and bolts, Storm introduces a new API, which is at a higher level of abstraction. It is called Trident. It is providing us with stateful, incremental processing on top of a persistent store, and it is based on Storm primitives. Here you will find the usual operations for data: joins and merges, aggregations, groupings, functions, and various filters. If we compare core and the Trident, we see that the core supports spouts and bolts. One message at a time is processed, we have a low latency, and we work on tuple of streams. With Trident, we are working with streams of data and operations on this stream, and the processing is organized in micro batches. We have a high throughput, and we work on streams of tuple batches and partitions. Several best practices of Storm. One thing that you may be tempted to use is a guaranteed delivery. If you do that, you may cause some performance degradation, so you need to be careful. You always want to monitor your applications. As you are writing code for your bolts, you would like to unit test that code. And usually we will be using various mocking frameworks and techniques to provide substitute for the other parts of the system or for the functionality that is not implemented yet. You should always integrate with conventional systems, and considering productivity, you should consider Trident